Guys, today my goal is to go through our last set of notes, and if you have them in front of you, there's not a lot to them. We're going to do 3 examples.
That's it?
That's it.
That's nice.
Yep. That being said, I mean, these examples are going to be most similar to like what a test or assignment question will be like. So they're not going to be like, 30 seconds long to finish. Like, it's going to take a little while to do them properly.
Are these questions that you are from the lesson yesterday?
Well, like, this is the second half of the lesson on inequalities. So, like, the stuff we did yesterday, this just continues it. Were you here yesterday? Okay. I'll try to fill in little blanks as I can if I do my best. Don't worry about it for right now. You'll pick it up as we go along, I think. Okay. I'll go over it later. Okay, you guys ready? Last set of notes for the unit. Okay. Yesterday we talked about inequalities. The only difference between an inequality and an equality is that you don't have an equal sign. You have a greater than or less than kind of sign. And the reason why I need to show you inequalities is because sometimes, probably not even just sometimes, in real life, you can often go up to a certain limit and use everything up until that point, but you don't have to go all the way to that point.
Equal to or less.
Yeah, the equal to or less than. Yesterday I gave an example of making cakes. If you have 2.5 kilograms worth of flour, you could make 30 cakes. But do you have to make all 30 cakes if you don't want to? Well, no, you don't. Sure, you could. Okay. Often these examples work really well when it has to do with money. You guys okay back there? Okay. Often these examples work really well with money because if you want to try to figure out how to minimize your costs, you'd like to try to find a way to drop your costs. For example, let's say you have $50 to spend on some stuff. But let's say you could get away with only spending $25. Wouldn't that be better? Like, you could spend all $50. Sure. But wouldn't it be better to only spend $25 and save some money? And that's where the whole less than or equal to things comes in. So let me try some examples today. First example, you want to build a table. And using this table, you need to have some aluminum and some glass. I kind of imagine the aluminum is for the rim around the top of the table, and the glass is for the top of the countertop. Does that make sense? The most that you have to spend, though, is $50. Okay, limited in terms of supplies.
Like a bedside table?
Yeah, that's what I was kind of imagining with this one. This wasn't meant to be like a kitchen table. Like a small coffee table.
I'll buy one leg.
Okay. So I'm going to give you some prices here. Glass costs 30 meters squared, and aluminum costs $3.50 dollars per meter. Okay. Let's say you built the largest table you could build possible. You could build a table and spend all $50 worth. But maybe you don't want to spend all $50. Maybe you want to build a slightly smaller table and have some money left over. That's also an option. Okay. So my first goal here, we want to write a linear inequality to represent this scenario. Before we do that, though, we have to figure out who x... Oh boy, now this stopped working here. I do. So I always have to like reboot it every once in a while. And now it's screwed up. All right, starting from the top. First thing we got to do is figure out who x and y are going to be. Okay. X, any thoughts?
Yeah.
How about this? How much aluminum you use? And then y would be how much glass you use.
Does it matter which one's which?
No,
Okay.
doesn't really matter which one's which, but pick one for each. Okay, well, how much does glass cost? Or let's start with aluminum. How much does aluminum cost? $3.50 for aluminum. So $3.50 x plus how much does glass cost? 30 for y. It has to be less than or equal to 50. Does that make sense? So however much aluminum you need for your table, and however much glass you need for your table, at the end of the day, that has to be less than 50. So you could have a lot of aluminum, you could have a little bit of glass. I don't really know how that's going to fit together, but it has to be less than 50 total. Okay. My next question here then is, can we graph this thing? And make like draw our graph. Do you guys remember what we did last day in order to graph this? What do we have to get? Go ahead.
We need to minus the 250x.
And what else?
Divide it the y by 3
Y.
to get the y by 3.
Okay, that's our purpose, yeah. Our y is to get the y by itself. Okay. So to get y by itself, minus 350x on both sides. Divide by 30. Divide the whole thing by 30. Here's your equation then. Y equals 50 minus 3.5x all over 30. And we're going to graph this thing. Okay, so when you're typing this in your calculator, does your calculator have the ability to do a greater than or less than symbol? And I don't think it does. Maybe the newest ones do, but don't worry about doing that. Don't forget the brackets though. So go 50 minus 3.5x, close bracket, divide by 30.
Right.
Okay, one more thought here. We got to figure out a good window size, because if I just graph this thing right off the bat, I may not get a really great picture.
Oh, it's just like a line.
Yeah. So let's talk through reasonable window sizes. X was about how much aluminum you could buy. You can't buy negative aluminum, so we should buy at least 0 aluminum. And then, I don't know, meters of aluminum. If I'm making a table, is 30 meters of aluminum a reasonable amount of aluminum? That's actually a lot of aluminum, 30 meters of aluminum. So that's probably reasonable. It's your Y value that's kind of screwed up. You can't buy negative glass, but we're probably going to need more than this for glass. So I'm going to make this 30 go up to, let's try 100, just see what that fixes it. Nope, that made it worse.
It made that.
Hang on a sec. Now that I think about it, 100 meters squared of glass
Like a big table.
is a really big table. I probably need less for that. I'm gonna start with 10 at least and see what 10 does.
Oh, 3.5 makes it look cool.
All right, 3.5.
3.5.
Why don't I go 4 then?
Okay.
Do you guys get about that?
Yeah.
By the way, just so you know, almost all of our graphs are like linear graphs that were backwards. Okay. Now I'm gonna ask you to graph this. So here's my expectations of a graph. Good enough. Minus a couple of important details. First important detail, you gotta label your axes. Don't label them as X and Y though. Label them as, what was X? Aluminum
Yeah.
and glass. And what did we go from 0 to 4? And from 0 to 30. It actually wouldn't hurt to put units in here. Glass was in meters squared and aluminum was in meters. So I would consider this to be a reasonable graph. I don't need it done like with a fancy ruler or something like that. I mean, we're talking approximate, but so long as you label everything appropriately, I'm content with that. Okay. Before I go on, let's talk about this a little bit. What does this intercept over here mean?
Where you buy only aluminum and no glass.
Yeah, this means that you spent all your money on aluminum and you didn't buy any glass. That's stupid. You need some glass for the table. This intercept right here means you spent all your money on glass and you didn't spend any money on the aluminum itself. So you have a nice big sheet of glass, but how are you going to make a table out of it? Okay. Chances are it's probably going to be somewhere in the middle here where you're going to choose to build your table. That makes sense. However, is there more than one way you can build your table?
Yes.
Yeah, so yesterday we talked about what's called a solution set. And a solution set is anything along this line, or even this point, or this point, or this point. Any point less than this line would be a valid solution. So we use what's called reverse shading. You guys remember this term from yesterday? We shade where the answers are not. Basically that means that everything over here, you don't have enough money to buy all this stuff over here. There we go. So for example, let's say you picked a point way over here of 25.4. 25.4 is not a reasonable point because you don't have enough money to buy 25 meters of aluminum and 4 meters of glass. You don't have the money. But you do have the money to buy anything inside here. Everything along the line means you spent all your money, and any point that would be like further inside here means you saved some money left over. Which would be ideal if you could, right? Like in a real world scenario, if you could find a way to make it so that this was how much glass and aluminum you used, you would have saved some money. But if you have to, you could spend everything. Okay, let's talk about the remaining questions then. So part A, we wrote the linear inequality. This right here would have been the linear inequality. B would have been graphing the solution, and I'm going to phrase this differently. To illustrate the solution set, your answer is a picture. So that's part B. Okay, now some questions about it. If you were to purchase 12 meters of aluminum, how much glass would you have left to be able to buy? Sure. Go to your thing here, do the value when x is 12. If we were to buy 12 meters of aluminum, we would have the money left over to buy 0.26666 square meters of glass. And normally I would ask you to plot that on your graph. And so that would be like, go to your graph, plot that point right here, and you would say if you used 12 meters of aluminum, you could buy 0.266 of glass. May not be that good to buy that much aluminum then, because 12 meters of aluminum is a lot of aluminum for a table. You might not want to build your table under those specifications. Well, sorry.
I just clued into
Modern table.
Yeah, it looks like cutting edge. Yeah.
It's
cutting
like
edge.
authentic.
Yeah. I don't know. It's like what you get when you go to IKEA. Yeah. I don't know. Okay. Next question here. How would the solution set change if the table had to have a minimum radius of 5 meters? 0.5 meters. Okay, bit of a twist here then. Let's say the table had a radius. What shape would the radius be then?
Square.
Circle. If it had a radius, it means we're talking a circle. Okay, so if you had to have a minimum radius of 0.5 meters, what that means then is your area of a circle. You guys know the formula for area?
Pi r squared.
Good, pi r squared. Okay. Well, if the radius has to be 0.5, sorry I'm running out of room here, but that means it's going to be pi times 0.5 squared. So pi times 0.5 squared. This means that I have to have at least that much glass bought. Otherwise, the table's just not big enough. Like in theory, I could make a table that is this big, but that's kind of ridiculous, isn't it? So what I've done is I've put a parameter on it saying we have to have at least a certain size of table. And apparently that size of table is, let's call it 0.79. Actually, let's call it 0.8 just to round things. Okay. So what I'm saying here then is your minimum glass has to be 0.78. Okay. Well, on your graph here, glass was over here. If your minimum glass has to be at 0.78, I'm going to put a new line on here at 0.78.
It can be anything on that line.
Well, it can be anything above that line.
What?
So here is 0.78, right about there. Okay. I'm telling you that you have to use at least that much glass. Otherwise, the table's too small. So what this means then is everything below this line means the table is too small. So I'm going to shade this section in as well, meaning now my table has a new parameter. My table has to have at least 0.78 for sure. But now here are my only remaining answers. The purple stuff means I use too much money. The red stuff means my table is not big enough. And so the remaining little triangle right here is the only solutions now that fit. Does that make sense?
That's actually pretty good.
So everything in here is a valid answer. This point right here, by the way, where they cross, would probably be the biggest table you can build using all of your aluminum. And money, yeah. So you'd be using all of your money up, basically, to make this table. So sometimes I throw a twist on the question, and rather than just having one graph, I'm going to throw a second line on there, and you're going to shade that in as well, meaning that this is where your answers lie now. Somewhere in that little triangle. Last question. Determine and label the vertices of the new solution set. Do you guys know what vertices are?
No.
Corners. Corners. Okay. How many corners does this new little white triangle have? 3. Okay. So if I'm going to label these corners, I need to find this point right here. I'm going to go with a new color. Sorry that it's getting messy. We need to find this corner here, and this corner here. So let me show you how to find them then. On your calculator, if you go value when x is 0, those are your y-intercepts. And this first y-intercept was up at 0 and 1.6 repeating. So that's at 0, 1 point, let's call it 1.7. Yeah,
These examples aren't small.
I don't like the way this is showing up very nicely. Let me try a different pen. Crayon? No, crayon won't show up very well. Magic marker. Let me try the creative pen. That's a bit better. Okay. So this would be at 0, 1.666. That is one of your vertices right here. Okay. Where's this vertice right here going to be at? Anybody know?
0 and 0.7.
Good. Yeah, 0 and 0.78. Basically, this means that you could have bought no aluminum and just bought in glass for the table. Kind of ridiculous, but I guess you could just make a table purely out of glass and rest it on top of concrete blocks. I don't know. An ugly table, but I guess you
Put
could.
it on your lap.
Sure, put it on your lap. That's a table. Yeah. Or you could buy a lot of glass and have a very large table. Or this point right here is probably the most logical point for the table, where you buy some glass and some aluminum. How do we find this point here? Good. Intersect it, yeah. Second, calculate the intersect. So the most logical possibility is to use 7.6 meters of aluminum and the 0.78 meters of glass. Are those the only 3 ways you can make a table though? Well, no. Anything inside this little white triangle would work. But usually what I'm going to ask you to do is find me the extreme edges and tell me where those are.
How did you get that line across that again?
So that line across there, I just said y had to equal 0.78. I just drew it right in there. Yeah, and that was at 7.6, 0.78. Does that make sense? Okay, let's try another one then. Like I said, we're going to do 3 today.
And then we have to work it.
And then tomorrow's the work day. Okay. Maybe more applicable example to some people. Farming. Farming. Delvers, yes. Okay, so imagine this made-up scenario. You're a farmer, and your fields, you only have 7 hectares of fields available to plant crops on. I actually have no idea how big that is in perspective. Justin, is that a lot of room?
I don't know what hectares are. I'm not good at
Never mind.
hectares. No acres.
Acres? How much would 80 acres be? Not a whole lot?
But hectares, I think that's.
It's a bigger unit, I think.
It's huge.
I
Okay.
think that's regional.
Okay, so you've got a big farm. Okay? Here's your issue there. At the beginning of the year, your startup costs, you only want to, and maybe these numbers aren't reasonable anymore, but you only want to invest $12,000 into your crops. That's how much money you have to spend at the beginning of the year. And it's going to cost you $300 to plant your corn and only $100 to plant wheat. Why would you not want to plant wheat just exclusively then? Well, sure, you may want to diversify. Also, the other thing is maybe corn makes you back more money than wheat does. Because when you eventually sell your corn, maybe corn's more expensive. So let's start solving this though. First thing you want to do is label your variables as x and y. So let's have x be how much corn you plant, and y be how much wheat you plant. Lisa, could you grab the door? Thank you. Oh, okay, so 197 acres in a hectare. Oh. So how much is 197 acres?
Like a field. It's
So
small.
small field.
Yeah.
Wait, 80 hectares is what? 197 acres?
Anyways.
No rolling.
Okay, let's try to write some inequalities. You actually have 2 inequalities in this example. Here's one of your inequalities. However much corn you plant, and however much, hey guys, give me your attention please. However much corn you plant, plus however much wheat you plant, your field has a limit. Your field is only 80 big. Yes. Thomas, could you grab the other door, please?
Can I go and tell them?
Sure, go tell him to be quiet.
Yes. Can you guys shut up, please?
Please. So polite. Please. Okay. Does that first inequality make sense? It's based on your space. You only have 80 hectares of space, so that's your topmost limit. But you also have another limit. You only have $12,000. And so the money you spend has to be less than 12 grand. Well, how do you spend money? Well, corn costs you $300 to plant, and wheat costs you $100 to plant. So this time around, we actually have 2 inequalities. That make sense so far?
Wait, 300 is what?
300 is how much it costs to plant corn. 100 is how much it costs to plant wheat. And your upper limit is 12 grand because that's all the money you have at startup. That makes sense? Okay, so that's part A. Part B, we want to graph these. Well, if I'm looking to graph these, I need to get y by itself. So in the first equation, how do you get y by itself? Subtract x. So one of your equations is y equals 80 minus x. The other one's a bit tougher. To get y by itself, you've got to subtract the 300x. Good. And then divide it all by 100. So I'm going to plot those in my calculator.
Should that be 1200?
12,000, sorry. Missed a 0, maybe when I was talking. Okay, so 80 minus x is one of ours, and then bracket 12 grand minus 300 bucks to plot one of them, divided by the 100 bucks it costs to plant the other one.
I think we should make it bigger.
We're gonna need to change our window size for sure, yeah. Now, I don't actually care what window size you use. so long as you clearly tell me what window size you use. Okay. So like if I were to press graph as it is right now, I don't think we see like anything. Okay, why don't we try 0 to 50, 0 to 50 maybe? That's not big enough yet. Oh, I have a better idea.
100.
I'm going to go to 80 actually.
Oh.
The reason why 80 is because 80 is the most we actually have for land.
Okay, that answer.
Yeah, let's go 0 to 80. Because what this means is you can either plot everything as corn or everything as wheat.
Oh, that's not.
It works on the one, but then the other one doesn't.
Oh, so should we go a little bit higher then?
100.
Okay, 100. Yeah, still not enough.
200.
140. I don't really care. As long as it shows up.
150 works.
There we go.
120 works. I like 140.
Okay, I don't care which one you used.
I was going to do
So when you graph this, draw me your two lines. I'll come take a look at 1 second too.
What was the
And
window size?
mine was 0 to 80 and 0 to 140. But if you have a slightly different window size, I don't really care.
Mine's 140 to 140.
Sure. First guy. Okay, one more thing I've got to do is I've got to label my axes. Axes? Axes, that's the right word. So what was X? X was how much corn I plant. And this is how much wheat I plant. Okay, let me talk about these two lines here. One of these lines, and I think it's this one right here, is about the upper limit about how much room you have in your field. Right here, you're planting only wheat. Right here, you're planting only corn. And so one of your issues is that you can't plant anything on this side of your graph because your fields are physically not big enough for that.
So gray out.
So I'm just gonna block out this section over here. What's the other line based on? How much money it costs. Yeah. Corn is actually quite expensive compared to wheat. Right over here, if you planted only wheat, you could plant a lot of wheat because you have all the money you need for it. Here's the problem though. Let's say you planted only wheat. You'd actually have money left over because you physically don't have the space to actually plant all the wheat that you'd like to. Does that make sense? Over here, if you planted only corn, you'd actually have unused field space because you don't have enough money to actually to buy and plant all the corn that you'd want to. That make sense at all? So when I do this graph I'm also going to have to shade the other side over here. And so I'm going to get 4 vertices. Here is a vertice where I plant only wheat. Here is a vertice where I plant only corn. Why not this one way out here at 80 though?
Because it's not shaded.
And I can't, in terms of like, I agree with you, but in terms of like logistically why? You can't afford to plant that much corn. That makes sense? Like, you can't afford to plant 80 hectares of corn because you don't have that much money. You can plant this much corn though based on your money. So here's where you plant all wheat. Here's where you plant all corn. Here.
You plant wheat and corn.
Yeah.
And you go.
And so you use all of your space, you use all of your money, and you found a way to plant all wheat and all, like some wheat and some corn. Okay. There is one more vertice, by the way. This is lazy farmer, who did nothing. In theory, I guess you could plant no wheat and plant no corn and just sit around. I'm not going to advocate for that, obviously. But I mean, technically, in terms of our solution set, that was a valid possibility. Anywhere in this white section there is now possible. So my question for you now is, let's find these vertices then. So to find one of the vertices, go value when x is 0. Here's the problem though. It may find the 80, or it may go up and find the 120 up there. And so you got to make sure you pick the right vertice, because it's actually the 81 right here that matters. So you could plant no corn and 80 hectares of wheat. That's a valid possibility. Okay. To find this guy right here in the middle, you got to intersect them. So second calculate, intersect. And then this one is 20 and 60. So you could plant 20 wheat, 60 corn. How can I find this vertice down here in the corner? Good, it's a 0, it's an x-intercept, yeah. Second calculate, a 0. Here's the only issue. You gotta make sure you're on the right line.
Okay.
As I go along here, you see how I'm on the wrong line? So to get it on the other line, you just press either up or down. So if I press down, now I'm actually on the proper line. And so then go here, here, and hopefully you can find that intercept. I got it at 40. Sometimes I'll ask you then to describe what this meant. So over here, you planted 80 hectares of wheat. Over here, you only planted 40 hectares of corn because you didn't have enough money. And then right here in the middle, you planted 20 and 60, which is kind of a nice optimal in-between ratio. The last possibility, though, you could have actually plotted 0 and 0. Anything inside this little shape right here is a valid way the farmer could afford to plant his stuff. I don't know which way he'll choose, but those are the possibilities. Does that make sense? Okay. Oh wait, one last question then. Do you guys want to take a break now or after the question? Doesn't matter to
What are
me.
you doing after?
Well, just some work time then.
Oh, after.
Okay, so let's just do this last question, then we'll take a break. Any questions on the previous one, though, before we move on? Okay, last one then. Marie wants to get some exercise, so she's going to swim and play tennis. I know these numbers are ridiculous because they're from like a couple years ago now. But here's some numbers. In 1 hour, she can burn 600 calories swimming or 450 calories playing tennis. So technically, if she wants to lose weight or like at least like burn off calories, swimming is better than tennis. But here's the problem. Swimming costs $4, tennis costs $6. So there's the trade-off. It's going to cost her more money to play tennis than to swim. One more problem. She has a weekly budget of $48 per week. What was that? Yeah, I think I did this backwards. Can we switch that? Can we make it so the tennis was $4 and the swimming was $6? I think I screwed that up. Because it seems more logical that it should be cheaper for the tennis than for the swimming.
I was like, then what's the problem?
Yeah. Then why wouldn't you just go swimming all day long? Because swimming is better for you and cheaper. Okay. Does that make sense then? Okay, let's write some linear inequalities. Before I do that though, I've got to define some variables. X and Y. Well, let's go with the activities. So X could be swimming. And Y could be tennising. I don't know, what's the verb for to play tennis other than to say playing tennis?
It's just tennis.
Because like swim becomes swimming, so to tennis means to
Let's go play tennis.
tennis. Yeah, but that sounds weird.
Let's go tennis.
Let's go tennising. Anyways.
Let's go tennis side.
Okay, let's write some inequalities here. I can think of one inequality. She only wants to commit 10 hours, no more than 10 hours. So X plus Y has to be less than 10. This is an equation based on how much time she has. She does not want to spend more than 10 hours a week doing stuff. That's one of her limits. She has another limit. Another one of her limits is she only wants to spend $48. So, let's see, swimming is now $6. tennis is now $4, and that has to be less than 48. And that's a money parameter. And there's one more inequality we can write. This time there's actually going to be 3.
Oh, whoa.
What information have I not used yet?
Calories.
Yeah. And it said that she wants to burn at least 5,000 calories.
Separate? 5,000.
So it has to be more than or equal.
Good, so it's got to be more than or equal to 5,000. Well, that's in a week though, right? So
So we have 3 separate.
let's see. Swimming is 600 calories. And tennising was 450 calories. So here are my 3 inequalities. 1 is a limit to time. They have to be less than 10 for time. Another limit she has is money. It has to be less than 48 for money. Third one is different. We haven't done one like this yet. But the 5,000 right here, she needs to somehow work out more than 5,000 in order to meet her, I don't know, workout requirements, I guess. So this is part A. Yes, the actual, like when you plot your graphs here, there's actually only a very limited solution set that actually fits this.
No wonder. I don't want to spend like
Well,
10 hours.
she's being a little, yeah, she's not giving a lot of flexibility here. Okay, the next thing we got to do is graph these things. So in order to get the equations, the first one is going to be y equals 10 minus x. The second one is going to be 48 minus 6x over 4. And the third one is going to be 5,000 minus 600x over 450.
So we have to draw 4 graphs.
3 graphs.
I mean 3 graphs.
3 graphs, yeah.
She would lose 1.4 pounds.
Based on how that works. Okay, so let's plot these. Does anyone have any questions as to how I made those equations, by the way? The whole subtract the x, divide by the leading coefficient? Okay. So one is 10 minus x.
Why are you going on my team?
I don't know. Because that's where it started. 48 minus 6x. It doesn't matter, really, does it?
It really matters.
Oh, okay.
Just kidding.
Whoa. Better be careful or you're going to go in the hallway and ask me to shut up, please. Please. Okay. In terms of window size, windows is about, like, the question was about swimming and tennis, and she only could do 10 hours at most. So before I even graph this thing, I'm going to guess for a good window size would be go 0 to 10 and 0 to 10.
You didn't even know.
Does Zoom Fit do pretty good? Where's Zoom Fit? Zoom 0?
I don't know. This is kind of. Oh, it's too small. It's too small.
The only issue I have with Zoom Fit is sometimes it may not. Well, actually, this one's not bad.
It has to be taller.
Yeah, I don't know.
Oh, 20
I did
works.
20. Yeah.
Yeah.
Works.
Oh,
Oh, there's 3 lines.
For what?
yeah, there's 3 lines.
Dang it. This is a lot of
About 15 probably would work too.
Yeah, this is
To be
really
honest, though,
crazy.
as I look at this graph right here, guys, we have a lot of wasted space.
Oh.
All this area up here is kind of wasted, and it's really hard to differentiate these 3 lines right here. So can I suggest that we maybe go like, say, 0 to 10, 0 to 10, at least for now? And try to limit how much wasted space we have?
But then the other line goes in the sky.
That's okay. That line probably is not a line we're going to work with just yet. How do we figure out which line is which, though?
I don't know.
Okay, another suggestion. How about we do them one at a time, then? Have I ever shown you guys how to turn off an equation by pressing the button over the
Yeah.
equal sign?
Yeah.
Okay, so let's just work with just the 10 minus x line first. This line right here said that we had to spend no more than 10 hours in the gym. which means we're looking for the section on the lower side. So on my y equals right here, if you go backwards and try to shade it, I want to try to shade the section above the graph so that it looks like this.
How did you do that? I didn't see that.
Okay, so go to your y equals, and then back here, if you go like back, it can make the upper side of the graph get shaded.
Crazy.
You just made it a thicker line. One more makes it shade the top side. See how that works? Okay. Did that make sense so far? I'm now going to go turn that graph off and work on the next graph. This one right here was about how much money she wants to spend. And so as I graph this guy right here, everything on the lower side of the graph means she's spending little money. Everything on the big side means she's spending too much money. So what I might do then is the exact same thing. I'm going to try to shade the top half of this, meaning that, again, the top half is where the answers aren't. That make sense? Okay, one more thought here. The last graph is going to be different because this one is that she wants to spend at least 5,000 calories. And so when I graph this one, I'm actually going to want to shade the lower section so that she tries to work out more than a certain bit. Uh-oh. I didn't turn the graph back on. That's why. So here's the last graph where we're trying to shade more than a certain amount. Okay. I think you guys are a little ahead of me. Now turn them all on. Put them all on.
Oh gosh. Whoa. It's like nothing.
There's nothing in my
Is there nothing that fits this?
Just kidding. Oh,
There is.
there is.
Where is it?
I don't see it.
I actually don't really see it.
I don't see it either, actually.
This doesn't work. She's just hopeless.
Oh, there is. Okay. Okay, so do this. Go zoom in. Justin, whereabouts was it? Like right in the center here?
Right in the center.
Okay, so try zooming in.
I didn't zoom in.
Go to zoom. Press zoom in. There we go. I see that little sliver in there too. So press zoom. Go down to zoom in.
I see it. It's
There's like the littlest of slivers there. How about this? Let me give you guys some window sizes to go from. Try going from about 2 to 6 and 3 to 6 as your window sizes, just to kind of start looking in there.
Wait, what'd you say?
2 to 6 and 3 to 6. I hope that helps.
My window's just not working.
I see it now.
Here, can you fix this?
No, I need to go a little higher there. So go 2 to 6,
Oh, why did
3
it go
to
like that?
6. And now you'll have what I have. But as I'm looking at this, I actually need to go a little bit taller, don't I? So that's my Y value. Let's go 2 to 6 and 3 to 7. And see whether that makes that little tiny sliver show up in there. It's not a lot though, is it?
This girl is picky.
Very much so. I think I can zoom in a little bit more actually.
How do you zoom in?
Okay, zoom.
Okay.
Zoom in.
Yep.
And then like put your cursor about where that stuff is.
Why is mine so big?
And then press enter. And hopefully now I'm going to get a nice, like this will be a little bit larger because I'm finally zooming in and actually seeing this section. That's better. Although to be honest, now I think I've zoomed in just a little bit too far because I can't see the edges of where that little white section was. So I'm just going to change my windows and make them go back a little ways. Let's make this go from 3.4 to 4.8. Let's see if I can make this show up nicely. And then I'll go from 5.2 to 6.5. Try these window settings. hope this is gonna work. There we go. This is better. Almost. Oh, I need a little bit further down. Okay, I need a little more Y direction.
More Y direction?
So I need to go like say 5.0 to 6 point, I don't know, not 8. Try these. Like keep messing around with them until you can finally see that little sliver in there. Okay. Oh my goodness, I still need to go a little further down, don't I? So make my Y min go down to 4.5. Holy smokes. I spent all of our time trying to make the graph show up.
I wish this would like go faster than like the lines.
No. Oh my goodness, now I need more X direction. Let's go to 5.1.
Wait, Windows 5.1 where?
X max is what I went to. Once I find it, I'll show you guys what my window size is, so we're all in the same place.
I did something wrong. What's XS scale mean?
Close enough. Good enough here.
What's scale?
Okay, so here's what I've got for my window. Try what my scale is here. 3.4 to 5.1, 4.5 to 6.8. But here's the thing. If you have a different window size, I don't care. Because here's what I want for you to draw. You're going to draw a graph that looks like this, 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 and you're going to shade everywhere else on both sides. Okay, and then you're going to tell me your window sizes went from 3.4 to 5.1, and they went from 4.5 to 6.8. And then we're going to label this as X and Y for swimming and what was it? Swimming and tennising? Okay, so we'll make this one be swim, and this one will be tennis. Very picky. Have you guys ever heard of the term optimizing? Or heard that phrase somewhere? Businesses might do this in order to try to find a way to reduce costs and increase productivity, but also increase profits. And there might be like multiple things you're doing at the same time. You want to cut costs, you want to increase sales, but you also want to increase productivity, you want to decrease waste. And so what you're going to do is you're going to create a whole bunch of graphs like this, and hopefully somewhere in the middle there, you find an answer where this is a valid answer. So we're almost done. All we need to do now is find the vertices for the solution set. So we've got to find this intersection point right here, this intersection point right here, and this intersection point right here.
So she could only be doing.
So anything inside this little region is where this would work.
Wait, which one?
So you got to find where these points cross, and these points cross by doing intersect. So. Here's the only downside is it may be kind of hard to see the stupid cursor on here right now. Can I give you guys a suggestion then? Go back to your y equals and take off one of the graphs and just do them one at a time. So find where the second set of graphs crosses. Because whenever you have 3 graphs on, it's kind of hard for it to solve.
Do the second one, so the second y equals?
So like what I did is I took off my I took off the 10 minus x graph, and so now what I'm going to do is I'm going to solve for this point down here by intersecting. And that one intersects at slightly off my graph. Of course, because my window's not quite big enough for it. I had to change my window size because this point is just slightly outside of the window size, it looks like.
Does our graph stay the same how you wrote it?
No, I changed the graph there.
So would this be 4.2? This one in the corner 3.4.
Did you find one down here in the corner? Ah, it's still not showing up. Go to 5.6. 4.0. Has anybody else had any luck finding any of these places where they cross yet?
I found two. Mine are like, I tried to do the y intercept, but then every time I did it,
Okay, that one works.
Okay, I think I finally found this one way down here. It's at 5.3 repeating and 4. That's this guy down here.
The one in the middle is 4 and 6.
This one is at 4 and 6. Okay, and then we gotta find this one way up here now.
Oh, finally I got that one. 3.3
Yeah, let me finish and see that we can get these three answers here.
Custom count is 3.3 repeating and 6.6 repeating.
So just so you guys know, if you ever get an error like this, the reason for the error is because your window is just not quite big enough. Because if the graph doesn't actually cross on your screen, it doesn't work.
4 and 6.
4 and 6 apparently is this point right here.
and then 3.3 being for 6.6.
For the top one.
There we go. 3.3 repeating
That one was the hardest one to find.
and 6.6 repeating. Okay, last thought here, then you guys can go for break. What does this mean? Well, this very picky person, here are some options for her then. She could swim for 3 1/3 hours and do tennis for 6 2/3 hours. That's a valid possibility. Or she could do 4 swimming, 6 tennising. Or she could do 5 1/3 and 4. All of these are valid options. Plus, any point that is inside of here is also a valid option to meet all of her parameters. But like we said, she's pretty picky.
Yeah, not many.
Last thought on this, then go take your break. It may be necessary for you to change your window size fairly drastically, and like you guys discovered with me here, that may be the biggest issue. So when you do your graph, all I care about is that you tell me where you started and where you finished when you graphed it. Okay? Because you might have a different graph than me or Justin or Lisa or whoever, right? So just tell me clearly where your graph is going from.
Okay.
Okay, go take a break. Thank you for bearing with me through that.